Okay, good evening everybody, or let's turn it on. I think it's a good idea. Good evening, my name is Demi. We'll be talking about a bit about cloud automation, security, and in general what we do at Panorays and about a use case. First of all, I'd like to start off with how many people here are software developers and security people. Great. So I think this talk will be in a good context for all of you. Feel free to be Israeli and interrupt me in the middle and ask questions, okay? Because if not, I'll just continue talking. Because it's a cybersecurity talk, we'll start off with a hoodie, and once we have that off the table, we can continue. And some important things about the talk. What I'm not, a Docker and Kubernetes expert. What you won't be after this talk is Docker and Kubernetes experts also. Basically, after this talk, you will be happier people because I've stopped talking. And you will know at least where to search and where to collect more information about Kubernetes and our use case at Panorays also, and you will know the meaning of life. A bit about myself. So I'm the VP R&D and the co-founder of Panorays. I will tell you a bit about what we do at the company also. I'm a Google developer expert. That basically means that Google certified me that I talk a lot. I also organize developer communities. One called Big Things. It's focused in big data, data science, and DevOps. And also GDG Cloud. Guess what? It's focused on cloud technologies. In the past, I was a software engineer at Windward, and around 8 years I was in the Israeli Air Force. There I developed the missile defense system. So, in general, when we're talking about cybersecurity, you can see a lot of malfunctions, a lot of things that go wrong. You can see that in these funny memes. But in general, we want to specify a few things in a matter of process. So first of all, when we're talking about security, we're talking about security in technology and not physical security. We're talking about actions and measurements that we can actually do to maybe prevent or to identify things. And of course, what technology people don't like are processes. Processes inside of organizations which slow us down, maybe, but also give us assurance that things are working correctly. So in general, when we're talking about any company or any entity in the world today, we're talking about assets. We want to always protect and know where our assets are. And when we're talking about assets, it's about files, identities, content, privacy of all of our information, and maybe pseudo-anonymity, etc. But when we're talking about protection and all of these things, basically we're talking about measurement that we can put in place to protect ourselves. So for example, if it's encryption, if it's multi-factor authentication, if it's VPN, or all kinds of things that we can put on our perimeter. But from what are we protecting from? When we're talking about threats, we need to think about, we need to think about all the things that we're trying to actually prevent. Phishing, malware, adware, exploit kits. It's pretty easy today for every kid, 15 years old, to download Kali Linux and try to attack and do malicious things. But afterwards, we need to think, who are these people who are actually trying to attack our organization or our own infrastructure? Which means spies, okay, nation states, hackers, ex-partners, malicious insiders, etc. So this whole landscape actually assembles the risk that we have on our entity or our company. So what do we do at Panorays? At Panorays, we help any company to manage the cybersecurity risk that is imposed by their supply chain. Today, we're using a lot of external services for everything, basically, okay? We left the world of, I'm protecting my own data center, I rock. I put a lot of effort into that, and I invest a lot of also, you could say, finance, millions of dollars, tens of millions of dollars on cybersecurity. But today you're using services for everything. For example, cloud service providers, emailing services, marketing tools, CRMs, ERPs, and all of your data is dispersed on the cloud, right? But we can talk about different kinds of vendors also, talking about our law firms, accounting companies. They're holding sensitive information and we're sending via emails all of these kind of things. So we help manage that whole life cycle of actually engaging with the suppliers and measuring their security posture also. How do we do that? We don't install anything in any party, not in the side of our customer, not on the side of the supplier also. And we're doing a full external perimeter overview from the outside. We're doing that in the hacker's point of view, doing the reconnaissance phase of the hacker, actually assembling the attack surface of any organization and measuring its security posture. We're doing these dynamic ratings 24/7. So we're basically monitoring all of the suppliers of our customers, and in the context of how our customer is using the supplier, we're measuring its posture. Okay, so this is in general what we're doing at Panorays. Problem. What's the biggest problem in software engineering? Can you give me ideas? Cache and validation. Really big problem, I agree. Anything else?
Correct deployment of software.
Correct deployment of software. This is correct also. Humans, the stupid factor, I totally agree with you. But if we're looking at that scientifically, it's naming. Okay? Most of our time as developers and people who do tech, we spend on actually like arguing about names. Okay? And because it's tech talk, I want to show something scientific. A research from Quora saying that more than 49% of developers and in general engineers say that naming is the biggest problem that they face on a day-to-day basis.
Isn't another way to name this conceptualization?
That conceptualization, I don't know.
Because when you look for a proper name, actually you want to see what kind of concept.
Exactly. You can say that in a matter of separation of concerns, of actually naming something super specific for its use case. I totally agree with that. I know. It's one of the hardest things of actually dismantling large components, the smaller ones, by naming them. But again, this is something that people argue about and stab each other as developers also. So to solve that problem, we need to do simple solutions, right? So first of all, we appointed a CNO, a Chief Naming Officer. This is the go-to guy for all the hardest problems. But let's talk seriously. Let's define the problems that we've had actually with managing the whole infrastructure on the cloud, because we're fully hosted on Google Cloud, running all of these scans in general to understand the attack surface of any company basically. And we used to run everything as a small startup company on regular VMs. So you would have a company being scanned by a VM that has a lot of code on it, actually collecting information. And once you do that, the parallelism level is being done by VMs. The whole scan process wasn't transparent enough because we had a lot of Python scripts running, and we couldn't know like more than logs that are on the specific machine what is happening during the process, and if something actually failed during the process also. Because most of our actions are I/O bound, and we're releasing traffic out of the machine, basically the CPU utilization was super low. So we're practically wasting money. And also, how many of you have tried to implement some kind of orchestration framework? How fun was that? None, okay? I'd rather take needles underneath my toenails also. And we used to do that with cron and bash, okay? Not fun. Trust me. How do you monitor everything? How do you know that everything is running correctly? Okay, and also you want to control that via some kind of API. You don't want to do anything manual because this just doesn't scale. So in general, like every startup company, we start off with the dispute of building a monolith and moving like fast, or building a cutting edge microservices architecture. How many of you are running microservices at your companies? Okay, fun, right? But eventually what happens, you start off with something and you end up with a microlith, okay? Because you start off with a monolith, you try to dismantle it to microservices, but eventually you end up with a big bunch of microservices that can be deployed only simultaneously, okay? And it's tedious, and you end up with a microlith. So in the beginning we had bin and bash, and then we had a virtual machine. Lots of virtual machines. Okay, and again, it becomes really, really costly. Everything was super sequential. You used to run all of the jobs. So if you have a huge company with a lot of assets, it takes you a really long time to actually scan. So we've developed the transporter. It's actually a dynamic workflow engine that works on top of Celery, if you know it in Python. It's a distributed task queue. Yeah, a question? No? Okay, awesome. So the transporter was supposed to be as flexible as possible and as efficient as possible. It was supposed to actually run things in parallel and also be fully automated. So you have a web UI basically, or some kind of API accessing the transporter, which is a web-based framework. It runs things through a task queue. So basically I give it like commands. I want to run a scan or a full scan or a partial scan on any company. It takes that task and dismantles it to two smaller tasks, running everything through the queue. And afterwards you have workers that take these tasks and execute everything on the Kubernetes cluster. So I'm kind of like flexible in 2 degrees. First of all is the amount of workers that can take things from the queue, and also the execution engine itself, Kubernetes, I can scale that easily also. And afterwards, all of the data is aggregated, and we present everything via web UI to the CISO. Okay, so how many of you know Kubernetes? Great, wow, it's a lot of people. Awesome. So I will say a few words about it. Kubernetes is a framework that is based on a framework that was developed in Google for more than 15 years. It's called Borg. They took all of the best practices of actually orchestrating, I wouldn't say Docker, containers in general. And it's fully written in Go, it's open source, and it's one of the most active open source projects today in the world. Okay? And it kind of solves the pain point, the problem of orchestrating a lot of Docker containers and taking the high availability to the next step. Most people, when they talk about Kubernetes, they speak about services, long-living services, exposing them to the web, replication, etc. They talk about labels, selectors, all of these kind of things that give us control over what's running on the cluster. But nobody actually talks about jobs. Okay, because not everything is a long-living service. A lot of things are batch operations that start, especially when we're talking about scans and things that we want to like distribute. It's basically jobs, okay, and big data workloads, etc. When we want to run that on Kubernetes. And this is the feature that we took advantage of Kubernetes, running that in large scale. How many of you have seen the movie The Transporter? Okay. How was it? Okay. It's a really cool movie and a really useless one because you have a lot of action that says basically nothing, but it's cool. But the movie had some fundamental rules that we kind of like took that to our world. The deal is a deal, no names, never open a package, and never make a promise that you can't keep. Sorry. So basically the deal is the deal. We took the whole like life cycle of a scan and we dismantled it to smaller pieces, talking about jobs, phases, workflows, and things that can run also in parallel and sequentially. And never make a promise that you can't keep. Basically having the whole mechanism of high availability and retries, schedules, and timeouts. It's given out of the box with Kubernetes once you actually implement that in a correct manner. Almost never make a promise that you can't make, because basically if you have too many failures and you have a cascading failure or like something that notifies you that something is wrong with your workflow, a lot of times you actually want to kill that. But eventually you keep retrying everything also all the time. And no names. Something special that we're doing at Panorays basically is having security researchers develop production code also, which doesn't happen much. I don't see that much in the industry. But again, we want to keep people close as much as possible to the what the customer actually receives and also to the production environment. So we kind of created the whole cocoon of Docker containers and the ability to create them really quickly and reliably and have them develop everything through that. And the orchestration framework actually takes care of all of the execution part. The good thing about security researchers is they're really descriptive. And they really like naming things. So we kind of got to the limitation of 63 characters of naming a Docker container, which more than that, basically everything fails. And you can't actually read that. So we kind of shifted in the middle of our development process to creating hashes of the names of the bots basically being ran, and we kind of created a mapping between them, because if not, you can't actually execute everything on Kubernetes. Okay, so what's on our cluster? Basically having the transporter service itself, worker deployments, Redis, and Kubernetes jobs being triggered by the transporter itself. Eventually, we got to some kind of point in which we kind of clogged our own internal network of Kubernetes because you have too much outbound and inbound traffic. So because of that, we separated that to two clusters. One cluster running actual services that are handling and also like executing all of the information, and the cluster itself that runs all of the scans. And then we added another like level of parallelism, let's say, and high availability to our products. So what's next? Okay, we're talking about like how cool is that using Kubernetes, etc. And it's like sounds like a silver bullet, but no. All of the workflow monitoring was really hard in the beginning. Okay, because you have a lot of moving parts. What happens when you're starting to scan like thousands of companies? It's really hard to actually manage that if you don't have some kind of mechanism in place and alerting mechanism also. So we created Grafana and dashboards on top of all of our internal monitoring system being kept in the database also. Config maps as versions. You stated the whole like deployment phase is really hard of actually like deploying quite rapidly and securely also. So for that, we wanted to actually have the version mechanism of Git and of Docker in general when you're deploying things inside our CI/CD process. So again, we've added more and more functionality. And asset level parallelization also, I don't want to be parallel also only in the matter of jobs and phases. I want to be parallel also in the matter of assets. What's happening, like for example, if I want to scan all of the subdomains of the company. I want to do some kind of analysis on that. Okay, so for example, in the beginning when we started, everything was consolidated in one Docker container, and we started like parallelizing that also. When I'm saying what's next, these are all of the things that we did in the past like year. Okay, because if we would waited of actually not deploying this kind of like piece of software, in general, our customers wouldn't have seen any value out of it, and we would ended up with some kind of failed project like most software projects end up with. Because if you don't hit the market, then basically you're in big trouble because you don't get feedback also. So we had a lot of problems in the beginning, okay? We ran A/B tests, basically running the old version simultaneously with the new version and tried to do comparison. But the main thing is actually hitting the market with some kind of product that creates value to your customers, and afterwards move forward as fast as possible to fix and add more functionality that is important. Okay. So, to conclude things. From my experience, I think in the past more than 12 years with distributed systems, if you have some kind of possibility of not developing a distributed system, don't do so, okay? If something runs on a really big beefy server and does the job, do it. Because it adds much more complexity. But if you don't have that possibility, actually do that on some kind of framework, an awesome framework like Kubernetes. And when I'm saying Kubernetes is a great container orchestration tool, basically it's because all of the industry had adopted Kubernetes as the main go-to tool that they're using today. What says that? Docker, okay, the company that created the format, had their own orchestration framework called Swarm, and they took Kubernetes as a running engine of Swarm. If that doesn't say that, I don't know what actually say that. Every cloud service provider, every even like on-prem cloud service that they're trying to create, maybe OpenStack, etc., does integration with Kubernetes. So it says
AWS is pushing
what? EKS?
Yes.
Of course, AWS. You have GKE on Google Cloud. You have AKS on Azure, and you have something by IBM that I don't remember exactly what it's called.
Nobody does.
Yeah, nobody cares.
What's the advantage? What's the advantage of using containers over serverless, Lambda?
Okay, so for example, if you're, I love this question. People ask me, why don't do that on actual serverless infrastructure? Okay, first of all, I am really predictable with my workloads. I know how much infrastructure I need to put in, okay, as long as I know how many customers do I have. And by onboarding that, it's really easy for me to actually tune that to get as much efficiency as possible. So I don't care about elasticity. But For example, Cloud Functions, Lambda, etc. They are really good when you're talking about like not complex, short-living tasks. For example, like in a matter of seconds. But what happens if a scan or a bot needs to run for minutes, or sometimes even half an hour? It really depends on the use case of what you're doing. Then you're not flexible enough. Or for example, if you have external dependencies, what do? If you have external dependencies, usually what they say in any serverless infrastructure, take some kind of pre-warmed Docker container that has all of the dependencies, and then we will do like the hot load in the beginning, and then you will have that in the cache, right? But if I'm like configuring a Docker container, I will rather actually like win the flexibility of using a real Docker container and a real Docker container orchestration flow. For example, if you have a really long pipeline of running serverless like actions, for example, like more than 5 or 6, then you get a mesh of like serverless functions being ran. How do you monitor that? You have a lot of startup companies that make a lot of money out of that. So Kubernetes gives me that out of the box. I have a managed service running on Google Cloud. I wouldn't like to actually ramp up a Kubernetes cluster myself. It's pretty useless. And it's possible also to install everything on bare metal if you're not able to run everything on the cloud. And today, everybody are actually offering like multi-tenant, okay, hybrid cloud, let's say, of running Kubernetes in one managed service or like one higher level master running on multiple environments or maybe like multiple cloud service providers. Yes. And of course, as I stated, perfect is the enemy of working or giving value. If we would start it of something and basically like create some kind of project of a year, we wouldn't have arrived to the finish ever. Okay, and this is the most important thing of actually deploying and moving fast, and maybe even killing the project. Okay, because it's not good enough, it doesn't give value, it doesn't move fast enough, and that's it. Okay, after I've talked really fast, and I think I did that pretty much the time. Questions?
Can you talk a bit about the CI/CD
Okay.
process?
The question was about our CI/CD process. So basically, we don't have CD yet, okay? And by D, I even don't mean deployment. I mean delivery. We kind of have it, okay? But the delivery process is actually today manual. Because why? We don't have enough tests, and I don't feel much assured about our code. But all of our CD process or CI process in general is with Jenkins running inside of Kubernetes also, and it ramps up the relevant servers according to what's needed. So basically we have like the development environment, staging environment, and production environment. And after we did all of these like cycles, and we have also like manual PAs that are working on the platform, we have, I would say, like really good assurance to our deployment process, and everything is, again, automatically by click, and not like every commit, you run the whole life cycle. You run the cycle until a certain point, and then you have a deployable version deployable version is something bad to say. I have multiple deployable versions. Why? Because we have Docker containers with different versions, and one deployment that kind of like aggregates everything, because I have bots in different versions. Okay, so by that I have some kind of topology that I'm deploying, and this is my current like high-level Uber version. And Jenkins is okay. It's better than anything that you have in the market because it's super flexible. And this was the important thing, and I didn't want to take it to an external service like Circle CI or Travis or whatever, because I don't know, I don't feel secure enough that way. A lot of times you fuck up and you have like secrets running, and you rather have that inside your own like VPC and not with someone. Any other questions? Awesome. Thank you very much for attending. And thank you also for Berta and Bobby for hosting us. And yeah, we're hiring something. Enjoy.